Als erstes möchte ich begrüßen Sjoerd und Luke von Polymaker, und die beiden werden eine wirklich interessante Masterclass machen. Ich freue mich sehr. Herzlich willkommen Sjoerd, herzlich willkommen Luke, und I think we're switching to English now.
I think that's better for everyone. Okay, if Luke is ready to put on the slides on the screen, then we can start. Okay, thank you very much for the introduction, Leo, and thanks for having us. Yeah, I think it's very nice to be here, and it underlines also the partnerships that we already have for, I think, more than 8 years. Welcome everyone on site and online. My name is Sjoerd. I am a sales manager for Polymaker, and I'm here together with Luke Taylor, our creative director, and marketing manager Gwen Kuiper. And we are here today to tell you more about our products. New product lines. I would like to start with a short company introduction that shows where we came from and what technologies we put into the products that we still, that we already start doing from the start and still do. So it's very important to highlight the role of R&D. It's you will see that's a recurring topic in the presentation that will come back. Then Luke will take over to tell you more about Fiberon, our new high-performance engineering materials, and I will tell more about PolyDryer, our active drying and storage solution, and we will close the session with an online marketing selection tool that perfectly connects also to what we are going to do outside. We're going to select materials based on properties and their features, and we're going to test that outside. So as long as we have time, we can do that, and if the time is over, we can just move outside. Short background story. Polymaker was founded back in 2012 as one of the first material companies. 4 friends from university started the company. They were all familiar already with 3D printing and would not say disappointed, but they thought they could do better, right, in filament production. So they started Polymaker with the goal to produce high-class materials. And nowadays we have locations worldwide. We have an office in Shanghai, and we have our factory in Changshu. We have a European setup in the Netherlands, where we have 20 people working for the company. And we have a similar setup in the US, where we have warehouses and an office, and also opened our factory last year to do production in the US. So like I said, this is our factory in China. We opened the factory September last year, so it's now active for 1.5 years. We built that from the ground up, and nowadays we have around 100 production lines worldwide, and we have production capacity of 8,000 tons of filament each year around. Also R&D here is a big role. So we compound our own formulas for 3D printing. So basically it means that we buy the raw materials, compound it to the best possible formula that's optimized for 3D printing, and also the technologies that we use inside the filament are all developed by Polymaker, and they're quite unique. So that's I think that would set us apart from some of the competition. In the US, we opened a factory fully automated. So we have automated spooling, we have automated packaging machines, and if this is a good concept, which it looks like, then we can maybe on the long term also start production in Europe. So take you back a little bit into the product history. I'm not going to highlight them one by one, but it shows you where we're coming from. So after the 4 college friends started the factory, they spent around a year in R&D, and they came up with the first material, which is PLA, and the good thing is, or the interesting thing is, that they developed the technology inside that filament, gem-free technology. I will tell you more about that later. That is still being used in our PLAs nowadays. You can really see here that they have a lot of R&D development in materials before they introduced materials. After a Kickstarter campaign, they introduced 4 more materials: another tough PLA, flexible, a wood-like filament, and a support material. I lost it a bit. And afterwards, they introduced more materials like PCs, ABS, castable material. And the slogan that we used back then was that if we introduce a new material, it should be either unique or best in class. That was kind of the brand that we want to set. High class professional materials. After 2020, the game changed a little bit. There was more like a volume thing coming up, so a lot of PLAs, more colors. So we were focusing more on the introduction of colors and just share and growth. And that's where we come now, where we restructure our portfolio. So we have still on the left all the Polymaker materials with ABS, ASA, PETG, PC. Then we move to Fiberon, which has our high performance engineering materials, kind of all the carbon filled and glass filled materials. And on the right, as we're going to talk about this afternoon, is Panchroma. Basically all the PLAs with different colors and surface finishes are placed in this category. And beside that, we still have our Polyterra Filament, which is sustainable like brand with less plastic content in it and on cardboard spools. And we really built a brand around Polyterra, so we will still keep on offering that as well. So coming back on the R&D and on the technologies, we have all Polymaker developed technologies in our portfolio, which are on materials. So the gem-free technology is in our PLAs. Basically, what we have done is we developed this thin coating around a PLA filament that makes sure that the softening temperature of PLA is 140 degrees and not 60. So this avoids a lot of nozzle clogging. Filament will not already heat up into the cold end, but only just short before the nozzle. Melts very quickly and then it's very reliable when you print it. Another unique technology is the layer-free technology, which we have with our polysmooth material, PVB based. This is a technology that you can use in combination with PVB plastic and isopropyl alcohol. Basically, you get rid of the layers in between the filaments. The warp-free technology, very nice to mention because that will also come back in the Fiberon presentation. That is what we have in our nylons. Basically, it controls the crystallization behavior of the polymer. So as soon as you print it, the crystallization is going on and it will not warp because the behavior is controlled by the technology. And it also makes sure that you don't need super high temperatures to print it. You don't need a heated chamber. So that it's very accessible to use our nylons on basically any desktop printer in the market. Very unique is the S3 technology as well. It's based in our polycast material. You can use it for investment casting. So if you print a mold, for example, for a low volume spare part example, you can build a ceramic shell around it, burn it out very cleanly. The residue is only 0.03%. And afterwards you can cast a metal inside and you have a very unique low volume spare part, metal spare part, for example. And the last one I want to highlight is the fiber adhesion technology, which also is coming back in our CF and GF materials. This is a technology where we kind of make sure that the fibers connect in between the layers to increase the mechanical properties in the Z direction. So you already have so strong properties in X and Y. But with this fiber adhesion technology, we can increase the Z direction mechanical properties with around 27%. We already discussed this one. Oh, there were some slides for it, sorry. So now coming back to the brands that we are introducing nowadays, it's on the left, Panchroma, with the slogan, your filament palette. You can find all the colors, the surface finishes in this brand. And now we're going to talk about Fiberon, high performance composite materials. Yeah, and I would like to give the microphone to Luke now. He's going to tell more about the Fiberon range. And I will come back later for the poly dryer.
Thank you, Sjoerd. So as Sjoerd mentioned before there, when we look at our company timeline, we introduced many materials through the years. And at some point, we sort of looked back at our portfolio and realized that actually it's a little bit confusing what we have here. So we wanted to sort of take all our fiber reinforced materials and rebrand them under a new product family, which is underneath Polymaker, give it a different look, a different feel, focus more on better technical data sheets, SDS, the kind of things that our customers who are buying these materials really need. And then on the other side, we'll come back to later, is much more about the aesthetics of the filament. So Fiberon, fiber in the name is because every material inside has fiber reinforcement, mainly carbon, but sometimes we have glass or carbon nanotubes, and in the future, maybe even some more exotic fibers like Kevlar or something like that. So right now we have 8 materials. So we had 5 materials already in the polymide family. Polymide being sort of poly and amide, so they're all nylon based. And then we added 3 new materials to introduce Fiberon just at the end of last year. So with the new packaging, we have a larger core on the spool. This is a 500-gram spool. It's actually the same size as our 1 kilo spool, so it's compatible with multi-material systems like AMS or Ultimaker. But we have a larger core, and that's because the carbon fiber filaments are much stiffer by nature. So if we wrap them around a smaller core, then it's a bit like a spring. So it's harder to unspool, and also the filament can tend to snap. So this is our standard size. It's a 500 gram. And then we also introduced a 3 kilo spool that you can just see over here. So we split our materials into 4 categories. At the top here we have the ultra performance, which is our new material. It's PPS CF, and then we have a high performance, which is like materials which have a heat resistance over 100 degrees. This is a heat deflection temperature with high modulus, high strength. Then we have general engineering, which is higher heat resistance than PLA, but with added stiffness. And this is our PETG RCF. What's interesting is we have a recycled carbon fiber. And then our special purpose filament, which is right now our PETG ESD. And this is actually using carbon nanotubes instead of carbon fibers, but I'll share more on that later. So here we have also all these materials are optimized for high-speed printing, right? So we fine-tune the melt index and play with the molecular weight to make sure that we can keep up with the speeds that the current printers and our customers are demanding. And also another optimization is that you don't require a heated chamber for any of these materials. So they can all be printed on open or enclosed machines. So starting at the top, this is our, let's say, our best performing material. It's a PPS-CF, polyphenol sulfide. And we say CF10 because it has 10% carbon fibers by weight. So an engineering plastic, I think if you look at the graph, it's really performing better than anything in terms of stiffness and heat resistance. What's really interesting about it is it almost has like a metallic quality. So here is a bell printed in PPS-CF. I can show that to the crowd online. So inside there is a clapper also printed in PPS-CF, and if you hear the metallic sound from the ring from a plastic bell, I think it's quite impressive what you can do. It's a bit of a gimmick, but it just gives you an idea on the capabilities of this material. Another very nice thing about PPS is it's not sensitive to moisture. So with nylons, for example, they are absorbing moisture, and there is you have to take a bit more care with your filaments, keeping them dry. Also, flame retardancy, naturally built in. It will score V0 on the UL94 test, and so really a really nice filament all round. It requires a high printing nozzle temperature, but apart from that, it's very easy to print. So that would be the only thing that would hold it back from being the most accessible high-performance material. So here we have just a couple example prints. Maybe Sjoerd can pass them around so you can have a feel for the prints themselves. And here we have a moisture test. So in this test, we soak the parts for a number of days just in water, and then we just weigh them after. Simply, it's a measurement of weight from before and after. And for nylons, for example, a PA6 will absorb up to about 3.5% in weight. But with the PPS, it's really unaffected. And here we have, this is our flame retardancy test, but more on that later. Oh, there's a video. So this on the left is N600. This is a raw PA6, let's say. In this test, it is a 3D printed sample printed at 1.5 millimeters solid, and to pass the test, the filament itself must self-extinguish. So we see the nylon on the left. Once it's been lit, it continues to burn. And it's obviously very bad if you're printing parts for your vehicles or anything related with the public. Generally always need fire-rated materials. So now we see the PPS CF on the right. So it will burn, but what makes it a fire retardant material is that it self-extinguishes. So we see no fire. So then moving down, then we have PA12 CF, which PA is a polyamide, and now we're getting into our nylon filaments. PA12 is also a CF10, so that's also a 10% filled nylon. Very nice material, performing very well. And if you compare, PA6, PA612, and PA12, often customers say, what is the difference between these materials? And it's all about the amount of carbon atoms in the polymer chain. So 12 stands for 12 carbon atoms inside the polymer chain. And then on the end of that polymer chain, there is an amide group. And it's actually the amide group where the moisture is being absorbed. So by having a longer chain, there's physically less room in the plastic for moisture to be absorbed. So PA12, in terms of its mechanical properties, from dry state to wet state, there is very minimal change. Whereas some of the other materials, we do see quite a significant change, and that can have its benefits as well as its negative aspects. PA612 is sort of our sort of all-rounder. It's in between. It's reduced sensitivity to moisture, but still having some of with slightly increased mechanical properties. Let's say if there's like a sliding scale from the best mechanical properties to sensitivity to moisture, there's no one nylon which is good at everything. So 612 is kind of that balance in between. And also it is slightly more affordable than the PA12. So here we have moisture absorption curve here. So our equilibrium is around 2.2%. If we go back and have a look at the PA12, it's around 1.5%. So here's a mechanical test for tensile strength. This is in the Z direction. So it's a printed sample, and then we pull it apart along the layers. So we're really testing the interlayer adhesion of the material. As Sjoerd mentioned before, we have the fiber adhesion technology, which is actually increasing this a little bit. But we see once the material is wet, there is a drop in layer adhesion. So the moisture is actually chemically changing the nylon. It's forming a polar bond onto that polymer chain. PET CF17, this is a semi-crystalline polymer, performs very, very nicely, very accessible material. If the 612 is kind of the all-rounder for the nylons, I think the PET CF17 is an all-rounder for the whole of Fiberon. Very affordable and very good performance, and it prints very, very nicely. It's accessible on I think almost every machine nowadays will be able to print it with a nozzle temperature of 270 at the low end. You can also go a little bit higher than that. Excuse me. And optimized for high-speed printing. So of all the Fiberon materials, I'm lucky I get to pick whatever I want when I need to make a print. This one is one of my go-to materials to print with, just as a good all-rounder. So again, we see here the difference between the wet and dry. Really minimal change. So the PET is unaffected by moisture. And here we have a case study of a part for a machining process. So it's really designed, I mean, it's a very versatile material. It can have many different uses, but this is the kind of use case that we expect our customers to use it with. Another advantage is the creep resistance. It's has a very stable material. So now we're moving into our our general engineering. We have the PETG RCF8. The R stands for recycled, and we are reusing the carbon fiber from wind turbine blades. So at the end of their life, the wind turbine blades are taken down, and the carbon fiber can be recycled. It's actually recycled by the TÜV Rhineland, you might be familiar with. So we are purchasing our carbon fibers in a more sustainable way, and that allows us to also reduce the cost of this material. So PETG is very common material already with good performance. This is our entry-level material into Fiberon. And then finally, our special purpose is the PETG ESD. The ESD is created with carbon nanotubes. The reason being that they are conducting the electricity or static electricity better. And what's interesting about this material is you can measure the surface resistivity across the material. The print orientation is actually affecting this. So if we see at the bottom here, with it printed at 90 degrees, we have different results to printed at 0. So actually you're getting more conductivity when it's printed upright. So yeah, it's interesting to know on how you design your prints or how you orient them on the bed if you're making some ESD cases, for example. Another thing is the printing temperature itself is also affecting the ESD. So in this case, there is quite a wide printing window on this material from 250 degrees to 290, and at 290 we get the best results. This also features our technology to improve the strength on this material. So it's impact modified PETG with ESD capabilities. Yes, so I think that covers the Fiberon materials. I'll hand back over to Sjoerd.
Thank you, Luc. Yeah, very important, as Luc explained, is that you store your filaments in a good condition. Especially nylons can be very sensitive to moisture. And yeah, we are a filament manufacturer, but since we also want to solve some problems, we have a few hardware products, and this is our latest product where drying meets storage. So it's our first active dryer system. The key features of this system is that you can build your own modular design. Right, you have one drying base unit, and you can take off the box and store it, and just put on another box to dry your next real filament. So that's quite different from other dryers in the market, where you either need to take out the filament or just print it straight away from the box. It has superior sealing with some very tight airlocks, and very efficient drying with a powerful fan and a good heating element. So dry and store in one solution. As you can see also in the picture, you can use one drying unit and use several boxes. You can build your own system. We also have some files in the package where you can print your things to put it on the wall, or you can put these on top of the dryer to stack them. So yeah, you can really make a nice setup. So maybe for the people online, yeah, sorry. And you never have to break the seal again. So as soon as you have dried the filament and you put it aside, you can be very relaxed that it will not absorb any moisture, because it has the best sealing performance in the market. And it brings your like the forgotten spools to life. We have a very even 360 airflow, and we have different drying profiles for different materials. Because we believe you cannot use one profile for every material. So you see a first power level for PLA and for support material, where you use the cycle for 6 hours. We have a second level for other materials, PETG, ASA, PVB and others, where you have different drying cycles, and a third level with a bit of a higher temperature for PA, PC and PVA. We are also introducing a new polydryer box XL later this year, that can also house bigger spools, has some different dryer profiles, and as it looks now, we can, with some add-ons, use the same power unit as explained here, so that people that already have a drying unit only need to buy the box, because that's a separate product. Yeah, as I just showed, you have STL files in this product, so that you can build your own setup. It's very nice to mount it on the wall or to stack it together. And we have some safety elements in here, so some elements that is protecting for overheating and for blocking any dangerous things with the product. So this is all secured in this safety controls. It's compatible with different spool sizes, and you can put it on different ways in the dryer. You can use the bearing reels, but you can also put it on the blue teal lid, and you can use it with 250 gram spools, 750 gram, 500 gram, or 1 kg, and later this year also with the bigger spools. It is a continuous drying mode on the power level as well. So if you have dried the filament, when you are drying the filament, you must really want to lock everything when the drying cycle is over. But using the continuous drying mode, you can also go around when you are not at home and don't need to come home after 6 or 12 hours when the drying is finished. The pricing of this product is on the market is €90 for the complete set. So drying unit in a box, and you can buy as many boxes as you want. So on average, we see that everyone that bought the whole poly dryer is buying 1.5 or 2 dryers on average, so that you can really say that people are really using the storage boxes after drying as well. Then I think we now move on to the comparison tool.
Yep.
Yeah, can click it online.
Yeah, I'll take over. Maybe you can pass the poly dryer around.
Yeah.
So to help our customers find the right material that they need, we've created a material database, which is a web app, and the URL is app.polymaker.com. So inside the web app, We have a few different ways to find the materials based on your needs. So it's a digital way to compare as well as with a color selection tool. So at the top here, we have our mechanical properties, and we can sort of select, okay, I need a material with impact strength, and we see actually our Polymax PLA is performing the best in terms of impact strength. And then we have a list of all our materials down here. On the left-hand side, you can introduce more materials. I see PC, the polycarbonate was not selected there. And if we introduce PC, we see PC ABS now moving to second position. So we have it's a breakdown of all our properties here. If we go into heat deflection temperature, then we see that PPS CF is far above here, and there's different ways to view the data also. And then at the lower end, then we have our PLAs here. So we also have a compare feature here. So if you're looking for this is a common comparison. We have a number of PLA materials which are tough PLAs, Polymax being the best performing, but a lot of people are asking, what is the difference between Polymax and PLA Pro? And here we can really understand a little bit more. So you see that in terms of impact strength, Polymax PLA is really outperforming, whereas PLA Pro has slightly better layer adhesion on the Z-axis tensile strength. And then you can select as many properties as you like here and really get a full comparison. You can add more materials in here, PA6 for example. Now we see PA6 is really the best performing in terms of tensile strength. We also have wet and dry results here. So this was something I mentioned before about the nylon materials, is that they are changing from wet to dry. And we see the biggest change in a PA6 CF, and that's something that we're going to witness also in the breakout session. So what happens is the material becomes let's say less stiff and more flexible. So for some applications, this can be very nice. For others, you want it to stay in its dry state properties, and there are ways to lock it in its dry state properties by coating it with a lacquer or an epoxy, just stopping any moisture being absorbed into the part. But we can assume that any part printed, well, first of all, it must be dry when it's printed, otherwise the moisture is boiling in the hot end and it's ruining the print quality and layer adhesion. That's why we have the poly dryer. But after a part is printed, then around, after let's say 30 days, then it will have absorbed around 3% moisture by weight. So we assume that everything eventually ends in its wet state properties. But as I mentioned, there is ways to lock it in its dry state. So this tool is available on our website, and you can just come here, search through all our materials, try and if you have a very specific need, hopefully the options are there for you. And then also we have a color matching tool, but I think we'll get into this a bit later when we talk about Panchroma. Yes, I think that covers this tool. Are there any questions about the app?
So we got another question regarding Fiberon out of the stream. How is it with refills regarding Fiberon?
So currently we don't offer any refills, but it is something that we are looking into. I think with the carbon fiber reinforced materials, there's an extra challenge with refills because the material is so stiff. So it is like a spring. So when it's wrapped around a cardboard core, for example, if it's unleashed too soon, it can really whip around like a spring and become quite uncontrollable. So it's about managing the customer experience with this, but it is something that we're working on.
Any other questions in in the room?
The ESD, does it get the ESD from carbon fiber as well? Or
From carbon nanotubes.
so smaller than in the other filaments?
Yes, yeah. I don't know too much details about the nanotubes themselves in terms of adding mechanical properties, but the reason is their conductive ability is better than the carbon fibers. Okay, then I think we are at the end of the presentation. So yeah, if you'd like to take 5 minutes, and then we can move outside and get a feeling for the materials in our breakout session, where we will do some fun things, try get a feeling of what each material is good for, or what kind of performance it has.
I have one question.
Oh, yes.
Do you have any experience about aging of your material? I have printed a couple of technical devices which are now 3 years old, standing in a normal floor or room. Do you know how the aging is and moisture is about that? Do they get weaker over time, or is it in normal conditions constant?
I think in terms of the moisture, once you're at equilibrium, then it's not changing after. So that happens over about a month. You will, with the nylon, for example, it will become slightly more flexible. You get and slightly less stiff.
Yeah.
But after that, then it's very stable.
Stable.
Yes.
Okay.
So there is also ways to moisture condition your parts straight away, so you don't have to wait for them to naturally absorb the moisture. And the moisture can also be baked out if you want to return it to its original properties.